In this video, we are going to practice identifying the asymptotes that rational functions have. This will help develop our skill with identifying whether we have a vertical, horizontal, or slant asymptote. So we are asked what type of asymptotes do these functions have, and we're given our choices, either vertical and horizontal, vertical and slant, only vertical, only horizontal, or horizontal and slant. So let's take a look at problems 1 and 2. So I'm given this scenario. The first thing I always do is I identify the vertical asymptote first. It is the easiest one to find because all you do is take the denominator, x plus 4, set it equal to 0, and solve. So it has a vertical asymptote at -4. Then I determine, does it have either a horizontal or does it have a slant? The way you do that is by looking at the degrees. The degree in the top is 1. The degree in the bottom is 1 as well. So that means the degree in the numerator is equal to the degree in the denominator. So therefore I have a horizontal asymptote, and that horizontal asymptote is going to be the ratio of your leading coefficients. So I have a 2, and this is a 1. So y equals 2 over 1, y equals 2. So which does it have? Does it have a vertical and horizontal, vertical and slant, only vertical, only horizontal, or horizontal and slant? And the answer, it has a vertical and horizontal. So A. Same idea. I will always find my vertical asymptote first. It is the easiest for us because it just takes the denominator x plus 4, set it equal to 0, x equals -4. So I do have a vertical asymptote. Next, I'm going to determine, does it have a horizontal or does it have a slant? And I'm going to look at the degrees. The degree in the top is 2. The degree in the bottom is 1. And so therefore, the degree in the numerator is 1 greater than the degree in the denominator. So I am going to have a slant asymptote. So I know to find the slant asymptote, what I'm going to do is take and do long division. Take x squared plus 3x minus 3 and divide by x plus 4. So what do I multiply x by to get x squared? I multiply by x. So distribute, you get x squared plus 4x. You are subtracting these, so I'm going to change all of my signs. This will become a negative x squared and a plus and negative 4x. So 3x minus 4x is negative x, and I have minus 3. So what do I multiply x by to get negative x? And that would be a -1. Distribute, and you're going to get negative x minus 4. We're doing subtraction, so we're going to change all of our signs for this. And what happens is I get -3 plus 4 is 1. That is my remainder, and we don't care about that when identifying our slant asymptote. Our slant asymptote is represented by this expression on top. It's the equation y equals x minus 1. And so I have a vertical and a slant asymptote, B. Let's do the same thing for 3 and 4. Here I have 2 over x plus 3 minus 1. So I'm going to determine my vertical asymptote first. I'm going to set x plus 3 equal to 0, subtract 3, x equals -3. Now the horizontal asymptote here, and I know it has a horizontal because of the degrees. The degree in the top is 0. the degree in the bottom is 1. So therefore, the degree in the numerator is less than the degree in the denominator. So what that tells us is y equals 0. I'm going to put this in a different color because that's not our horizontal asymptote by itself. Y equals 0 is the horizontal asymptote of this rational function. I have yet to look at this minus 1. I'm just working with the rational function right now. So y equals 0 is the horizontal asymptote of this. But what I'm doing to this y value of 0 is I am subtracting 1. And so therefore my horizontal asymptote is the y equals 0 minus 1. So y equals -1. So if you have a constant after your rational function, you need to realize you're identifying the horizontal asymptote of the rational part. And so the horizontal asymptote of the whole equation, you're going to have to take that constant in consideration for it. So y equals -1 is my horizontal asymptote. So I'm asked, which one is it? A, B, C, or D? And A is if you have a vertical and horizontal asymptote. So let's look at number 4. This is interesting because my denominator is not factored. If my denominator is not factored, what I'm going to do is I'm going to factor it. This is a difference of squares, x plus 3, x minus 3. That allows me now, when I identify my vertical asymptote, to set each one equal to 0 and solve. So x equals, here I would get -3, here I would get +3. So I have two vertical asymptotes, one at x equals -3 and one at x equals +3. And now I go for identifying if it has a slant or horizontal. So the degree in the top is 1. The degree in the bottom, if we look at the original, was 2. So that means the degree in the numerator is less than the degree in the denominator. So I have a horizontal asymptote at y equals 0. And we have two more examples. Let's focus on identifying our vertical asymptotes here. This will be a little more complicated because my denominator is 6x squared plus 3x minus 9. It is not completely factored, but I notice 6, 3, 9, they're all multiples of 3. So I'm going to factor out a 3. So I get 2x squared plus x minus 3. This is your AC method of factoring. 2 times -3 is -6. You want factors of -6 that add up to a +1. Well, that would be 3 and -2. So I break apart this b value. I keep the a x squared. I keep 2x squared. But I'm going to have plus 3x minus 2x minus 3. GCF here is an x. Factor that out, I get 2x plus 3. GCF here is a -1. Factor that out, I get 2x plus 3. So the factored form of 2x squared plus x minus 3 is my 2x plus 3. They have that in common, and I'm left with x minus 1. And so if I'm going to identify my vertical and horizontal asymptotes, I set each one of these equal to 0. So vertical asymptote for 2x plus 3, I would subtract 3 and divide by 2. So that would give me -3 halves. And I would, x minus 1 equals 0. I would add 1 and get x equals 1. So again, I have two vertical asymptotes. Now we're going to identify what our horizontal or slant asymptotes are. And so we have a degree of 3 in the top, a degree of 2 in the bottom. The degree in the numerator is 1 greater than the degree in the denominator. So I'm going to have a slant asymptote. Well, it's time to do long division for this. I am going to be taking my 2x cubed and divide by my 6x squared plus 3x minus 9. Now here's the interesting part. 2x cubed, if you just write that by itself, you're going to think, well, you can't have three terms go into one term, but you need to remember there's really a 0x squared. There's really a 0x. There's really a constant of 0. You need to remember to insert any missing terms with a 0 coefficient. So now we can actually do our long division. How many times does 6x squared go into x cubed? Here's what I would do. How many times is x squared? What do you multiply to get x cubed? You multiply by x. So I'm going to take care of the variable first. The coefficient's a little more complicated. What do you multiply 6 by to get 2? Well, to go from 6 to 2, you may be thinking, well, I divide by 3, but I'm not asking what you divide by, I'm asking what you multiply by. So how do you show dividing by 3 by multiplication? You multiply 6 by 1/3 in order to get 2. And now I distribute. So 1/3 of 6 is 2. I'm going to get 2x cubed. 1/3 of 3 is 1, so I get plus 1x squared. And 1/3 of -9 is -3, -3x. We are subtracting all of these terms, so I'm going to change all the signs. This becomes a negative, this one becomes a negative, and this one becomes a positive. And then just perform the vertical operations. 2x cubed minus 2x cubed cancels. 0 minus 1, so I'm going to get negative x squared. 0 plus 3, I get plus 3x. So I have plus 0. And now again, what do I multiply 6 by to get -1? Well, you would divide by, -6. So dividing by -6 is the same as multiplying by -1/6. Now I could distribute, but if you take a look, the reason why I line up my x's by my x's, my constant by my constants, and so on, is because it allows me to know when I am done with my long division. I can't go any further. So whatever I get here when I do the distributing, it's going to give me my remainder. So there's a reason why you line your x squareds above your x squared, your x's above your x's, your constants above constants. It lets you know when you're done and you don't have to go further when doing the slant asymptotes. So my slant asymptote is represented by the equation y equals 1/3 x minus 1/6. And so we still have one more example left, but what I'm going to do is I'm going to give myself some room because I went over under number 6. So let me grab all this and move it over. And let's do number 6. Now this one's going to be interesting. I have 7 over x squared plus 4, and the reason why this is going to be interesting is because of, well, how do you identify your vertical asymptote? You set the denominator equal to 0 and solve. So x squared plus 4 equals 0. X squared equals -4. Well, you square root that. Square root of 4 is 2. And you're going to have the square root of -1. So it's 2i. Can you really have vertical asymptotes that are imaginary? No. So there are no vertical asymptotes. So let's now identify our horizontal or our slant. So the degree in the top is 0, the degree in the bottom is 2, so the degree in the numerator is less than the degree in the denominator. That tells me right away horizontal asymptote at y equals 0. So I hope you found this video helpful with practicing identifying your vertical and your horizontal asymptotes and your slant asymptotes with rational functions.